Okay, today we are going to start our new chapter, Polynomials. So first of all, let us define the term. What is the meaning of the term polynomials? Since this term is consist of basically two terms, one is poly and the second one is nomials. The meaning of poly is many and the meaning of the nomials means number of terms, means it is the expression which consists of many number of terms. Now we come to the general expression of the polynomials. So basically, what is the general expression for polynomials? I can write, if my polynomial is defined in variable x, then how I can write? It is p of x is given by a0 plus a1x plus a2x square plus a3x cube plus dash up to an x to power n. Okay, now by looking this expression we can observe that this expression is a polynomial in variable x. So except x, the terms which are appearing in this expression, these all are constants. Means here a0, a1, a2, a3, these all are the constants. So we can write where a0, a1, a2, a3 up to an, these are constants and these can take real values. Okay. And what about x? X is our variable in which our polynomial is defined. Now if we observe the terms of these polynomials, we have observed that the variable in which our polynomial is defined, the exponent of the variable is an whole number. If we look at the first term, the exponent of x is 0. If we observe the second term, the exponent of x is 1. And if we observe the third term, the exponent of x is 2. Means here exponent of variable x must be whole numbers. So we can write index or exponent must be a whole number. Okay, after this we come to the degree of the polynomials. It is our next topic. So what is the basic meaning of degree of polynomial? Degree basically related to the, it is the coefficient of, it is the exponent of the highest power of x in which our polynomial is defined. Means here our polynomial is defined variable x, so we have to check the highest exponent of the variable x. So by looking this expression we can see here the exponent of x is n and which is maximum, so the degree of this polynomial is n. So degree can be defined as, degree is the exponent of variable x okay, which is maximum. And the other condition we apply for the definition of the degree, means an must not be equal to 0. Why this condition we have applied? If an becomes 0, then the last term of this expression will become 0. So this is the basic and the foremost condition for the polynomial whose degree is n. An must not be equal to 0. Otherwise this polynomial will not have degree n. Now we can understand this thing by some examples. If we take first example, okay, if I write x square plus x plus 1. By looking this expression, we can see that here the degree of x is 2, means the variable in which our polynomial is defined is x and the highest power of this variable is 2, so degree of this polynomial is 2. Okay, if we come to the other examples, root 3x square plus x plus 2. If we observe this expression, here also the degree of this polynomial is 2 because we have to observe the index of the variable. It is not concerned with the coefficients of the variables. So here the degree of this is also equal to 2. Okay, so in such type of examples we can observe the variable in which our polynomial is defined and we have to check the highest power of that variable. This is our degree. Now we take some examples. We have to check whether these expressions are polynomial or not. I am writing root 3x square plus x plus 1. Next one is x square plus 1 upon x, and next we can write x plus x raised to power 1 by 2 plus 2, and next is x square plus x divided by x. Okay, out of these examples we have to check which are the polynomials and which are not. Now we check the each and every expression. First of all, if we come to the first expression, here if we observe the exponent, since our polynomial is defined in variable x, so we have to check only the exponent of x. If we check this polynomial, here we observe that all the exponent of x are whole numbers, means it is our polynomial. Okay, so this is polynomial. If we observe the second expression, here the exponent of the variable in the first term is 2, which is whole number, there is no any problem. If we come to the second term, then we can write this term x square plus x raised to power minus 1, means here the index of the variable x is not a whole number, so this expression is not a polynomial. So what can we write? Not a polynomial. Now if we observe the third expression, if we observe each and every individual term of this expression, the first term of this expression is x raised to power 1. Its index is 1, means it is our polynomial whose power is 1, means there is no problem in the first term. If we check the second term, here the x raised to power 1 by 2, which is not an whole number, so this expression is not an polynomial, means here we can write not a polynomial. Now we come to our last expression. Here x square plus x divided by x. If we separate the two terms, then we can write x square divided by x plus 1. If we observe the two individual terms, in the first term the exponent of x square by x, can I write x plus 1, means here the exponent of the variable is a whole number, so this is also our polynomial. So in this way we can check the expressions whether they are polynomial or not. The basic and the foremost condition is that we have to check the power of the variable in which our polynomial is defined. Okay. After this we come to the classification of the polynomials. How can we classify polynomials? So first of all we write down classification of polynomials. Okay, we can classify polynomials on the basis of two criteria. The first criteria is on the basis of number of terms, and the second one is on the basis of degree. Okay, now how can we classify on the basis of number of terms? We can classify on the basis of number of terms into three categories. The first one is monomial. Okay, and the second one is our binomial, and the third and the last one is our trinomial. Okay, if we want to classify further on the basis of number of terms, then there is no particular name for it. So if the number of terms are more than 3, then we will just simply say this expression is an polynomial, and there is no any specific name for this expression. We have classified on the basis of number of terms. There are only 3: monomials, binomials and trinomials. Okay, we will come to the separately, we will study about all these polynomials separately first. Then we come to classification of the polynomials on the basis of degree. So how can we classify on the basis of degree? The first one classification is constant polynomial. Constant polynomial. Okay, and what is our second? Okay, and the second one is linear polynomial, and after it we come to quadratic polynomial. Quadratic polynomial. Then we come to our next classification is cubic polynomial. Okay, and the last one is biquadratic. So these are the classification of the polynomials on the basis of number of terms and on the basis of degree of the polynomials. Now we study about all these classifications separately. So first of all, we come to the classification of the polynomials on the basis of number of terms. On the basis of number of terms, we have classified polynomials into 3 categories. First one is monomial, second one is binomial, and the third one is trinomial. So first of all, we see what are the monomials. So first of all, we write monomial. Okay. Now, first of all, what is the meaning of monomial? Monomial means the polynomial having only number of terms is equal to 1. Means the any polynomial which has number of terms is equal to 1 is defined as monomials. So what are the examples of the monomials? So first of all, we can write down number of terms in the polynomial expression will be is equal to 1. Okay, now we come to the examples of the monomial. What are the examples of monomials? First one is x plus 1. The first one is x. Okay. Now what are the other examples? I can write x square, and what are the other examples also? X to y. It is also our monomials. Here two variables are appearing in this expression, but they can be clubbed into one term. So it is also a monomial. What are the other examples? X, y, z. These all are also monomials. Now tell me about what about this expression? If I write x plus 2x minus 3x, what is this expression? So basically, by observing this expression, we are looking that this expression consists of basically 3 terms. So you will say it is not a monomial, it is a trinomial. But if we observe this expression and if we simplify this expression, then what can I write? I can write x plus 2x minus 3x means, yeah, one more thing which we can add, 3x plus 4x. Okay, this is our expression. Here it has number of terms is equal to 4. Okay, now we check this expression. The value of this expression after simplification, 2x plus x is 3x, plus 7x minus 3x is equal to 7x. X plus 2x 3x plus 4x. 7x minus 3x is equal to 4x. Okay, so value of this expression will come out to be 4x. So after simplification, here the number of terms reduces to 1. So if we are given some such type of expressions, then we have to simplify this expression. Then we can conclude about whether it is a monomial, binomial or trinomial. So it is our monomial. Okay. Now we come to our other classification after monomial. What we have read? This is binomial. So how can we write about the binomials? Binomials means they have number of terms is equal to 2. Okay. Now what are the examples of the binomials? This can be x plus 1. It has number of terms is equal to 2. So it is our binomial. X square plus 1. This is also example of binomial. And xyz plus 1. This is also example of binomials. Okay. Here we observe that these all expressions have number of terms is equal to 2. So these all are our binomials. In this category also, if we take the same example, if I have given an expression 2x square minus 3x square plus x. Now if we observe this expression, then we conclude about this expression that it is a trinomial because it has number of terms is equal to 3. But what we have to check, first of all we have to simplify this expression, then only we can conclude whether it is a monomial, binomial or trinomial. So if you observe the first two terms of this expression 2x square minus 3x square, this can be written as minus x square plus x. So our final expression is minus x square plus x, which has number of terms is equal to 2, so it is a binomial. So by just observing any expression, we cannot say that it is our monomial, binomial or trinomial. We have to solve this expression. Okay, now we come to our third classification, which is trinomials. Now how can we classify trinomials? First of all we write trinomials. Okay, so what is the meaning of trinomials? Means any polynomial which has number of terms is equal to 3 is defined as trinomial. Means in any trinomial number of terms will be 3. Now we come to the examples of trinomials. What are the examples of the trinomials? We can write x plus y plus z. It is an example of trinomial. Okay, now we come to the other examples. If we write x square plus x plus 1, it is also trinomial. What are the other examples? Root 3x square plus x plus 2. These all are the examples of the trinomials, because in all these expressions number of terms is equal to 3. So these all are trinomials. Okay, so now we have completed our classification on the basis of number of terms. Now we come to our classification on the basis of degree of the polynomial. So we have already classified polynomials on the basis of the degree. So first of all we come to the first category in the degree. What was our first on the basis of degree? So what was our first polynomial which you defined? It was constant polynomial. Okay, so what is the meaning of the constant polynomial? Means if I defined my polynomial in variable x, then how can I write p of x is given by 2. Means if I write p of x is equal to 2, this is our constant polynomial. Here the right hand side of this expression can take any value which is a constant. Means if I substitute in place of x is equal to 1, the value of this expression comes out to be p of 1 comes out to be 2. Okay, so we can see if we change the value of x, the value of this expression does not change, so it is our constant polynomial. So in the same way, if we substitute x is equal to 2, then what we get? P of 2 is equal to 2. So by looking these expressions, we can say that the value of this polynomial remains constant, so it is a constant polynomial. Okay. Now if we talk about the degree of the constant polynomial, what is the degree of this constant polynomial? Here if we observe this expression p of x is equal to 2, Okay, so how I can write 2 into x raised to power 0? Is there any problem in this expression? If we multiply 2 into x raised to power 0, the expression remains same. So the degree of this constant polynomial is 0. Means we can write degree of this constant polynomial is 1. After constant polynomial, we come to our next classification is linear polynomial. Okay, so what is the basically a linear polynomial? Okay, if my polynomial is defined in variable x, then how can I write? We can write f of is equal to ax plus b. This is our linear polynomial, but still there is some term is missing. We have to apply one more condition for this expression to say a polynomial a should not be equal to 0. Means this expression will be a linear polynomial if a is not equal to 0. Because what will happen if a becomes 0? If a becomes 0, then the first term of this expression will become 0. Okay, and only what remains? F of x is equal to b, which is not a linear polynomial. It will become a constant polynomial. So this is the first and the foremost condition which we have to apply, that a should not be equal to 0. So this is the general expression for the linear polynomials which has degree 1. Here if we observe the exponent of the highest power of x which is equal to 1, so degree of this linear polynomial is 1. Okay, so this was our general expression, and what are the examples we can write in linear polynomial? We can write 2x plus 1, or it is our linear polynomial because here the exponent of the highest power of x is 1. So it is our linear polynomial. And then the other condition, 2 is not equal to 0 because the coefficient of the highest power of the x is not equal to 0. So it is our linear polynomial. So for any expression, we have to check whether it is a linear polynomial or not. We have to check the highest power of the x, which should be equal to 1, and the coefficient of that power should not be equal to 0. Then only we can conclude that it is our linear polynomial. So both the conditions are must. Now we come to our next classification. What was that? After linear we come to quadratic polynomials. Quadratic polynomials. Okay, so what will be the general expression for quadratic polynomials? If my polynomial is defined in variable x, then how can I write? F of x is equal to ax square plus bx plus c. This is the general expression for the quadratic polynomial, and this expression will be a quadratic polynomial only when a is not equal to 0. So this is the basic and the foremost condition for this expression to be a quadratic polynomial. A must not be equal to 0. Otherwise it will be linear polynomial, because if a becomes 0, then coefficient of the x square will become 0 and it will be a linear polynomial. So this is the condition which we have to apply whenever we say any expression is a quadratic polynomial. Okay. Now what is the degree of this quadratic polynomial? For degree, what we check? For degree we have to check the exponent of the variable in which our polynomial is defined. Okay, so here the variable in which our polynomial is defined is x, and what is the highest power of this variable x is 2. So degree of this quadratic polynomial is 2. Okay, now what are the examples of quadratic polynomials? X square plus x plus 1. Okay, if we observe this expression, here the variable in which our polynomial is defined is x, and what is the highest power of that variable is 2, means it is our quadratic polynomial. Okay, if I write, it is our quadratic polynomial. If I write x square plus x raised to power minus 1 plus 1, what about this expression? If we simply look at this expression, the first term is x raised to power 2. means it has the highest exponent of variable x is 2, means it is a quadratic polynomial. But if we observe the other terms of this expression, if we come to the second term, here the exponent of x is not equal to a whole number, so here our condition fails, means it is not a polynomial. Okay, so we cannot get a say this is a quadratic polynomial. So first of all, any expression, if we are saying it is a quadratic polynomial or not, first of all we have to check whether it is a polynomial or not, then we can say it is a quadratic polynomial. So it is not our polynomial. Okay, so sometimes this is the general mistake which we make. We have to observe the complete expression, then we have to conclude about that expression. Okay, now we come to our next classification. What was that? It was cubic polynomials. So how can we write about the cubic polynomials? Okay, we come to the general expression for the cubic polynomial. If polynomial is defined in variable x, then f of x can be written as a x to the power 3 plus bx square plus cx plus t. This is the general expression for cubic polynomial. And what is the condition we have applied? Here the exponent of the highest power x, a, which should not be equal to 0. Okay, then only it is our cubic polynomial. Okay, now we come to the examples of the cubic polynomials. What can be the examples? X cube plus x square. Okay, this is our cubic polynomial because here the exponent of the highest power of x is 3. So it is our cubic polynomial. Okay, what are the other examples? X cube, it is also cubic polynomial. Okay, so basically classification of polynomials on the basis of degree does not depend on the number of terms. Okay, we have to check the highest power of the exponent of variable in which our polynomial is defined. It is not concerned with the number of terms appearing in the expression. If we observe the first expression, here the number of terms is equal to 2, but it doesn't matter. Okay, what we have to check? We have to check only degree of the polynomial. So here the degree of polynomial is 3, so it is our cubic polynomial. So these are the examples of cubic polynomial. Now we come to our last classification, which was biquadratic polynomial. Okay, biquadratic polynomial. Okay, so first of all we write the general expression for the biquadratic polynomial. So what is the general expression? If our polynomial is defined in variable x, then f of x can be given as a x to power 4 plus bx cube plus cx square plus t. And what is the condition we have to apply here? A must not be equal to 0, otherwise it will not be a biquadratic polynomial. Okay, so what is the degree of this biquadratic polynomial? Here the exponent of the variable x is 4 and the coefficient of is not equal to 0. Okay, so degree of this biquadratic polynomial is equal to 4. Okay, now if we look at the examples of biquadratic polynomials, what are the examples? We can write any polynomial which has degree 4, means x is to power 4 plus x is to power 3. It is our biquadratic polynomial. And what are the other examples? X4, simply it has number of terms is equal to 1, but it doesn't matter for us. We have to check the only highest power of the x in which our polynomial is defined. So it is also our biquadratic polynomials. If I write this example, x is to power 4 plus x plus 1 upon x. What about this polynomial? Whether it is in biquadratic or not? Okay, so if we observe the first term of this polynomial is x to power 4. So just by looking the first term, we can't say it is in biquadratic polynomial. We have to check the complete expression. The first term there is no problem, it is okay. In the second term it is also okay. Now we come to the third term. Here the exponent of the variable x in which our polynomial is defined is not a whole number. it comes out to be -1. So this expression is not a polynomial. So we have to take care of all the things which are defined for the polynomials, then we can classify on the polynomials. So it is not a polynomial. So there is no meaning to say that whether it is a biquadratic polynomial or not. Okay. So we have classified polynomials on the basis of degree. Now if we want to say if the polynomial has number of degree of the polynomial is 5, then what will be the its classification and what name is given. So basically only we have classified polynomials up to biquadratic polynomials. After the polynomials which comes into this category, they have not any specific name, they are simply known as the polynomials. Okay, so we have classified up to constant polynomial, linear polynomial, quadratic polynomial, then cubic, and then biquadratic. And after the polynomials which come, they will have no specific name, they will simply known as the polynomials. Okay, now after it we come to the value of a polynomial at a particular point. This is our next topic, value of a polynomial. Okay, so value of a polynomial means we have to find the value of polynomial at a particular point. If my polynomial is defined in variable x, then how can I write p of x is equal to anything, any expression, we can write ax plus b. Okay, this is our polynomial where a is not equal to 0. Now we have to find the value of this polynomial at a particular point. Suppose we want to find the value of this polynomial at a point x is equal to alpha. So how can we do this? For finding the value of the polynomial at a particular point x is equal to alpha, simply what we do? We substitute x is equal to alpha in the place of x in the expression of the polynomial. So p of alpha can be given by a alpha plus b. This is the value of the polynomial at a point x is equal to alpha. Okay, if we look at the examples of this, we are given a polynomial f of x is equal to x square plus 2x plus 2, and we have to find the value of this polynomial at x is equal to 1. This is our question. So how can we do this? For finding the value of this polynomial at point x is equal to 1, what we do? If we come to the solution of this question, we want to find value of this polynomial at x is equal to 1. So what we do? Simply we put this x is equal to 1 in place of x in the given polynomial expression. So we have to find f of 1. What I have done? I have put x is equal to 1 in the polynomial expression. So where the variable x is appearing, we have to replace it by x is equal to 1. Means what is our term? 1 square plus 2 into 1 plus 2. So this is equal to 5. So value of this polynomial at point x is equal to 1 is equal to 5. So this is the example from where we can conclude that how can we find the value of polynomial at a particular point. Okay. Okay, now we come to the other examples also. If we have to find, we are given our polynomial f of x is equal to x square minus x plus 2. Okay, then find its value at x is equal to 2. Okay, how can we do this? In the similar way we have followed in the previous question. How can I find? What I have to do? I have to put x is equal to 2 in the place of x. So f of 2 is given by, okay, this is 2 square minus 2 plus 2. Okay, if we simplify this expression, then the value of f of t becomes 4 minus 2 plus 2. Okay, so this is equal to 4. So value of this polynomial at point x is equal to 2 comes out to be 4. Okay, so this is the way by which we can find the value of the polynomial at a particular point. After it, we come to our next topic, which is root or zero of a polynomial. Okay, zero or root of a polynomial. So basically, what is the meaning of this zero or root of a polynomial? So if we observe the term zero, means the term simply specify its importance. Means we have to find the zero of the polynomial, means we have to find the value of x at which the value of this polynomial becomes 0, which is defined as the zero of a polynomial. Okay, 0 and the root, these are the both same things. We can say both, we can use both the terms, 0 as well as the root, but in case of polynomials we generally use the term 0 of a polynomial. The term root will be used in the case of the equations. Okay, so here we will generally use the term 0 of a polynomial. Okay, now we come to the how can we find the 0 of the polynomial. If my polynomial is defined in variable x, then how can I write? F of x is given by ax plus b. Okay, where a is not equal to 0, this is my polynomial in variable x. Now I have to find the 0 of or root of a polynomial. Okay, so how can I find this? Means we have to find the value of x at which the value of this expression becomes 0. Means what I can do, I put ax plus b is equal to 0. Now ax is equal to, if I transfer b to the right hand side, then x is equal to minus b. Okay, so what value we obtained? We obtained x is equal to minus b upon a. So this is the 0 of this polynomial. Okay, so this is the method by which we can find the 0 of a polynomial. Simply what we have to do, we just equate the complete expression is equal to 0, then we find the value of x. So this value is known as the 0 of the 0 or root of the polynomial. So this value x is known as the 0. Okay, or we can say root of polynomial. Now we come to some examples of the 0 or root of the polynomials. Okay, what can be the examples? Okay, we have to check whether x is equal to 2 is a 0 of polynomial f of x is equal to x square minus 2x plus 2. Okay, so what is our question? We have to check whether x is equal to 2 is a 0 of polynomial or not. So how can we do this? If we come to the solution of this question, okay, what I do, I simply substitute x is equal to 2 in the place of x, then I get f of 2 is equal to 2 square minus 2 into 2 plus 2. Okay, so value of f of 2 comes out to be 2. Okay, so f of 2 is equal to 2 means value of this expression at x is equal to 2 is not equal to 0, which is equal to 2. So x is equal to 2 is not a 0 of this polynomial. Okay, what we have to conclude? Any particular point x is equal to alpha will be a 0 of polynomial only when if we substitute this value in the expression of the polynomial and the value of the expression comes out to be 0, then only we can say that it is the 0 of that polynomial. Here f of 2 is coming out to be 2, means we can write f of 2 is not equal to 0, so we can say it is not a root of polynomial.